So without any delay, let's start understanding arrays in C#. Many applications that you'll build are in need to work with sets of data. While creating this course, I was actually struggling to come up with a real-life application that I've built myself that did not require the use of lists. If you think of an HRM application like the one we are building for Bethany Spy Shop, surely we'll come at a point where we are in need to work with a set of data. It could perhaps be a requirement that we loop through a set of all employees and that we calculate the wage for each employee. We'll need a structure in C# to store all the employees. Maybe while you're following this awesome course, you have some background music playing using your favorite music streaming service. You probably have created a playlist. Well, that too is a set, a list. In the future, you'll probably write a C# application that connects with a database and that will read in a set of records. As you hopefully understand, the number of times that you'll come across a list of data, well, is pretty huge. But couldn't we just declare a number of variables to store all this data? Well, while that would work, it would be rather limiting. In many cases, the amount of items that we'll have in the list is in many cases unknown upfront. So declaring variables won't cut it. We'll need a structure that supports storing a set of items. And to support this, C# has in general two ways of handling sets of data. The one we'll look at here is arrays. And next to arrays, C# also has rich support for collections. Arrays, as we'll soon see, shine mostly when we are working with a fixed number of items in the set. Collections, on the other hand, offer a more flexible approach where the number of items can grow and shrink, based on what is needed in the application. Arrays are a bit simpler to get started with, so let's look at these first. Arrays in C# are a built-in structure in the language, which allows us to store multiple variables. Indeed, in one single array, we'll be able to store a number of variables. When working with an array, these variables all need to be of the same type, and this type needs to be specified when creating the array. Items within an array can be accessed using an index. The index is the number in the sequence the item has. In C#, everything is zero-based, meaning that the first element can be accessed using index 0. Now, creating an array requires a bit of a special syntax, so that C# understands that we in fact want to declare an array. As mentioned, upon creation of the array, we must specify the type. This is the type of items that this array can contain. In the first line, that's again just int, but then notice that the type is followed by a set of square brackets. What I'm doing here is declaring that I'm going to create an integer array variable. The name of that variable is here all employee IDs. Now, to be clear, adding the square brackets makes C# understand that we have the intent to create an array, not a single variable of type int. Next to using just a primitive type like int, we can declare arrays also of just any type, even custom ones. Here in the second line, I'm declaring an array of type datetime, in yes, the exact same way as we did for an integer array. Startdates is the name of the variable. So far, we have in fact done nothing more than creating the variable. The array doesn't exist yet. Hey, we've heard that before. Doesn't that sound like instantiating a class, a reference type? Indeed, great remark. Arrays are reference types. They are stored on the heap. And yes, that happens no matter what type of elements we are storing inside of the array. So even our integer array will be a reference type, and it will be stored on the heap. All employee IDs here in this sample is just a variable that points to the array. Now let's look at the right of the assignment. There we see indeed that I'm again using the new keyword, and then we specify the type. Again, followed by a set of square brackets, and in between these we need to specify the size of the array. Here I have defined 4, which means that this array will be created so that it can contain 4 integer variables. It's only when we use this new int here that the memory will be allocated. So after executing this line of code, what will happen is that all elements are created and a default value will be used for initialization for each of these elements. So in essence, here 4 integer variables are created and they all receive their default value of 0. Now just to be clear, arrays that we create are reference types. No matter what the type of the array will be, we created an integer array and that will be created on the heap. If we create an employee array, as we'll do later, the exact same thing will happen. Only when we are calling onto the new keyword are we in fact creating the array and all elements are initialized with their default value. If the type of the integer is int, the default is 0. If we define an employee array, all elements will be initialized with null. Another important aspect for arrays is that their size is set when the array is created, and it cannot be changed. So if more elements need to be added to the array after what has been set at its creation, the only option that we have is to create a new array and copy over all the elements. The original array cannot be changed. If that would be a requirement in your application, collections, which we mentioned already earlier in this module, might be a better fit. In C#, arrays are zero-based, meaning that the index for the first element is 0, then 1, and so on. Now, although the size of the array is fixed, it is possible to specify the length only at runtime. This length could be, for example, a value that we asked the user, or it could be a calculated value. Here you can see a snippet where I'm asking the user, using the console again, to enter a numeric value, and that is then set as the size of the array. Now we know how to create the array, but we don't have any data in it yet. At this point, all elements are still their default. There are multiple ways to do that. We can in fact, upon creation of the array, already pass in values for each of the elements. In this case, we are looking again at the integer array, and now notice I'm passing in initialization values. Integer values, that is, in between curly braces. I'm using constant values here, but these two could be a value which is only available at runtime, so a calculated value. The number of items that we pass in the initializer part, though, must be the same as what we are indicating as the length, so 4. For that reason, the second line here will cause a compiler error. Since there we are still saying the array should have a length of 4, but we're only passing 3 values in the initializer. We can, however, omit the size value if we pass in an initializer, as you can see in the third line here. Now, of course, we won't always know the elements we want to store in the array upon the creation of the array. Now, we can, of course, access the elements also after initial creation of the array, and this way also specify a value for the individual elements. Through an indexer, we can access individual elements. In the first line in the snippet here, I'm setting the value for the element at index 0. And we can also access the values of an element, and that's what I'm doing in the second line here. We can again access the values through the use of an indexer. Here in this line, I'm passing 1, so we're trying to get the value of the second element in the array. Since that is, in our case, an integer, the value can be assigned to another integer variable. Now, do pay attention. As I mentioned, arrays have a fixed size. If we try to get the value of an index that doesn't exist, we'll get an exception. Now, this will be a runtime exception. The compiler doesn't know about this. And we'll see later how we can handle this through exception handling in our code.